My name is Nayan Hajratwala, and I'm talking about technical practices and kind of looking at them through the lens of Kanban. Um, this is designed primarily to be a talk for non-developers and to try and get people exposed to some of the practices that they might see in their organizations happening and hopefully demystify them a little bit and then try and see how we can relate them back to the Kanban principles and core practices. So this is a view from my balcony, so that was kind of nice. It has nothing to do with the talk other than that. All right. So you guys have probably seen this in plenty of presentations so far. These are the four Kanban foundational principles. Start with what you do now. Agree to pursue evolutionary change. Initially respect current processes, roles, responsibilities, and job titles, and encourage acts of leadership at every level in your organization. All right, so those are those core practices: visualize, limit WIP, etc. All right. Okay, and then, we'll go through them real fast. Okay, so these are some extreme programming technical practices. So if you're familiar with extreme programming, it's it's a full agile methodology. Very similar to Scrum in respects, except that it has a whole set of technical practices as well, which Scrum does not have. And these are just some of them: pair programming, continuous integration, simple design, collective code ownership, test-driven development, and whole teams. Whole teams isn't necessarily a technical practice, but I think it's important enough to kind of include. All right. There are also a bunch of other technical practices that are commonly used in the Agile space these days, including acceptance test-driven development, mob programming, which is kind of a newer up-and-coming thing, clean code, continuous deployment, feature toggles, refactoring, feature splitting, and evolutionary design. So I'm going to go through, I think, most of these. There might be one or two that I've dropped at this point, but most of them we'll go through. All right, any questions before I continue? And feel free to ask questions during the presentation. Okay, so the first one up, continuous integration. How many folks are using continuous integration in their orgs? Yeah? All right, good. So that's a good thing. These are just some examples of some continuous integration tools. Jenkins, Hudson, Concourse is the fan. That's kind of a newer one. Go is the ThoughtWorks thing. Bamboo is made by Atlassian, the same people who do Jira. Okay. So the basic way that continuous integration works is you have a bunch of developers, all very happy developers, of course. And I got to get closer to the thing. Okay. So they check in code into their source code repository, right? So everybody's using source control, I hope, right? Okay. And whenever anybody checks in to the source code repository, that triggers a message over to this continuous integration server. Okay? And that continuous integration server does several things. It'll check out the code from the source repository. It compiles the code. It runs all the tests. It builds all the artifacts. And then notifies the team on any sort of failure. Your CI server could potentially do more things than this or less things than this. It just depends on where you are. But this is a pretty standard set of things that a continuous integration server does. So given these things, any feelings about what Kanban practices these might relate to? What's that? Feedback loops, yes. Implement feedback loops. Anything else? All right. So that's actually the only one that I had on that slide. So this is just a screenshot of a continuous integration server on a project that I'm working with. Right now, you can see that they're having a little bit of trouble with build stability right here down at the bottom. This is showing like percent successful builds, and recently it's not been successful very frequently. So I think there was a bunch of changes going on with just the actual build infrastructure itself. And this shows like successful, 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 failed, successful, successful, failed, etc. That's what those little indicators are. So you can get a very good idea of, is your code in a releasable state at any point in time. So what do we think about this as far as Kanban practices? Yes? Yes is not a Kanban practice. But it's good, yes. Visualization, right? Yeah. So visualize. All right. Okay, cool. All right, so the next one is continuous deployment. So again, most people are doing at this point continuous integration, so I don't think that's anything unusual. Is anybody here doing continuous deployment? And when I say continuous deployment, there's some little bit of terminology confusion that some people have with continuous delivery versus continuous deployment. Usually when we talk about continuous deployment, it's every check-in results in a production release. Not a potentially releasable software, but actually a release into production. So places like Facebook and so on will do this type of release, and it's moving that way. That's the trend in the industry right now, is towards this continuous deployment. When we talk about continuous delivery, that's usually our code is in a releasable state at any point in time, and then we can just, when our business owner says, yes, release it, then we can release it out into production. Okay, so that's the difference there. Okay, so, all right, so the first stage, again, we start with our happy little developer, and they check code into the source control repository. Usually the way this, and this is just an example of a deployment pipeline. All deployment pipelines are different, but they all have some similarity to this, okay? So check in code into their source code repository. This continuous integration server will build the artifacts and run the micro tests. You might have some automated acceptance tests that run after that. You build a environment in which it runs. So a lot of times this is something like Chef or Ansible or Puppet, which is going to actually build the servers for you, perhaps in Amazon Web Service or Rackspace or something like that. And that way you're building fresh servers every time, so you don't have any cruft left over on it from a previous run. You then deploy out to production, potentially in an A/B type scenario where you're only deploying, you deploy to kind of like a standby server. Your production one is ready to go. You might then run some smoke tests against the newly deployed code, and then flip that A/B switch and go to production. Potentially then you would do some monitoring to make sure that the production system is running as you expect, or that there hasn't been any sort of performance degradation or anything like that. And then if there's any sort of failure, notify the team and or roll back. Oftentimes when you're doing continuous deployment, you don't actually notify on a successful release just because it's happening so frequently. So you really just want to notify on the error conditions. Whoops, got a little graphical error there. Probably can't see it from the back. Anyway, so this is where things are going in the industry, and I've found that it's helpful to think about this even for teams that are not necessarily planning to do continuous deployment, at least in the near term, because sometimes it's hard to think about how would I get from where I'm doing monthly releases or even quarterly, or not quarterly, but monthly or bi-weekly releases. How would I possibly get from that to multiple releases per day into production? And it's hard to envision that sometimes. But if you start thinking about it, it often pushes you to think about what are the bottlenecks in my system that are preventing me from actually doing this, and how do I address them? Because we know that it can be done. So it's just a matter of, could it be done in your organization? The answer is probably yes. It's just difficult, possibly. So anyway, so it's a nice thought experiment anyway. So any thoughts on what Kanban principles or practices this might be related to? What's that? Managing flow? Let's see. Oh, limiting WIP. Well, yes, I think managing flow is as well. They can't all be winners, right? So this limits, the way that this limits WIP is that you are only talking about one thing at a time, right? So each of these stages, like the micro test stage, you're only testing one commit, right? You're only deploying one commit at a time. So you have a very low work in progress through your build pipeline, right? I think that, so we've also got visualize, the same type of thing. You're seeing your changes in production right away. And, kind of stretching the words, visualize isn't necessarily that's what it means in the, Kanban foundational principles, but I think it still kind of applies here. And yes, managed flow also I think is a good one. And these are by no means like the definitive list. I mean, I'm sure that other people, you could probably think of other ways that some of these things could map correctly. So, yeah, so I think managing flow is really good because you are now actually kind of in a state of this single piece flow, which is kind of like the ideal state, right, of a production line. All right. This making policies explicit also, you know, I kind of feel like this is an interesting one because you are, the policy that we're talking about here is that when you commit code, it will be in production, you know, probably in about 30 minutes or less, you know, Domino's Pizza. So, so I think that's actually a pretty explicit policy, okay? And then, of course, implementing feedback loops as well on failures. And also, actually, I should have actually mentioned, you know, any point in this pipeline, if there's a failure, then notifications would occur and feedback would occur. Okay. All right, so very closely related to continuous deployment is this idea of feature toggles. Anybody using feature toggles at all? Feature switches? Cool, that's great to hear, great to hear. So this is a screenshot of Chrome, so Google Chrome. And if you do this little thing up here, it says Chrome://flags, you can get to this page. And basically what it's got is a whole bunch of feature toggles. So what this says is, you know, we've got this first experiment that they're running is override software rendering list. I have no idea what that is, but currently it's disabled, and you could click this, and if you wanted to enable it, you could just turn that on in your browser. So it's some feature that they've already built. It exists in your browser, but it's just not on, okay? So it's not released per se. Okay, so but it's releasable. So as soon as, so presumably you can, a bunch of engineers, perhaps internally, or product owners internally to Google, are turning this flag on, making sure that it works, and if everything looks good, then at some point they will release a new version with that flag actually enabled. Okay. So, and then if you're familiar with their Canary product, Google has a product called Chrome Canary, which is basically like, it's kind of like a beta release of Chrome. It stays, you know, a few cycles ahead of the Chrome release. And it's, if you look at the flags page for Canary, it has a bunch more of these things enabled by default, as well as even more advanced things that are coming down the pipeline. So that's kind of a fun thing to play with as well. All right. So this one we've got implementing feedback loops, managing flow. Again, it's all about the business being able to see things out in production quickly and get feedback on that rapidly. So, and I don't know whether they do it in Chrome, but a lot of times when you do feature toggles, you might have some sort of statistics gathering or something like that to see how many people are actually enabling it and whether it's a worthwhile feature. All right. Feature splitting, one of my favorite subjects. So that tree is a feature. It's getting split pretty hard. Okay. Feature splitting. So, all right, so we have this feature that says a traveler can book a flight. Okay. And this is in our fancy new travel reservation system that we're building. So our customer comes to us and says we'd like to have this new feature that says a traveler can book a flight. And Brad, what's the estimate? How long do you think it's going to take us to get this done? All night? Oh, good for you. No, I don't mean to actually book the flight. I mean build the system to book the flight. A weekend. All right, you're hired. Okay, so most of the time we don't know. I mean, this is a big feature. Okay, so there's a lot of things that could go into this. So what if we were to take a little slice of this and we said something like this? A traveler can book a one-way flight. Okay, so then we'll just consider one-way flights for right now. It's still a useful piece of functionality. You know, maybe people aren't going to be super excited about it, but you know, it's you know, at least people who need one-way flights could do it. So you know, how long is this going to take now? Well, about half as long as it would have taken the previous one, maybe. But it's still kind of a big thing. And of course, this is just an example, so I don't actually have any real numbers for this. So we don't really know how long it's going to take. So what if we split that even more? Instead, a traveler can book a one-way flight that starts at Detroit, which is where I'm from. So even less time. So again, a possibly useful feature for people like me who live in Detroit and I guess only go to places and never come back. I don't know. But you know, it's an example. All right? So again, this is still too big. So let's split it again. So a traveler can book a one-way flight, starts in Detroit, and arrives in San Diego. And we can kind of keep going down this path, and we still don't know. And so then we say, well, this flight's you can only book the one that starts at 10 a.m. and arrives at 1:25 p.m. And I say, okay, that'll take me 2 days to build. Okay. And so now we're kind of at a nice little place. And usually when I'm coaching teams, what I talk to the developers about is, I think Matt did a thing about no estimates, and he's doing another thing about no estimates coming up, I think, in the Slack zone. But usually when we talk about estimation, it's really, do you think you can get it done in a day or two? If not, let's split it, and let's figure out ways to split it, like, this arguably poor example. But let's figure out ways to split it such that we can still deliver some sort of value, but in a shorter time, okay? And just keep splitting it like that. Now, this has some interesting side effects. So one is that you are limiting WIP. So we're only, it's limiting WIP in the sense of batch size, right? So you could think of like that large thing that you were trying to deliver as a whole bunch of different pieces of work that you just have clubbed together. And so in that sense, I think you're limiting WIP. And you're also, at least when I work with teams, I am making that policy explicit about that 1 to 2 day time frame. Okay, so the other nice side effect is that when you have that giant feature, oftentimes you start splitting it down, and it turns out that the things that you end up building, so we built all of these lovely beige sections, and we haven't gotten around to building these little bits yet. But at this point, we're ready to ship it. It's good enough. Our customer says, you know what, we don't actually need to build that little piece. But if you're just if you are focused on that giant feature, it's really hard to know when you're done, or you just build too much. So this is probably the most effective way that I've seen companies cut scope. So it's really hard for people to look at a backlog and when projects are having trouble especially, and say, oh yeah, we'll cut this, we'll cut this, we'll cut this. But if you take each story as it comes in, or each feature as it comes in, and decompose those into these 1 to 2 day chunks, inevitably there'll be stuff that will just fall off. So I've never met a feature that couldn't be, de-scoped through this technique. Unless it was a feature that already only took 2 days. So I think this helps manage flow. And that's it. That's all it does. Just helps manage flow. I don't know. There's probably more as well. Okay. All right. So ship it. Okay. So any questions so far? Yeah. Potentially. I tend not to even worry about that too much. Getting teams to the point where they can do this effectively, usually you would do it in whatever is the highest business value type of a thing. And I mean, at the same time, usually when we're working on this idea of 1 to 2 days, in reality what happens is that 1 to 2 days is usually like about 5 or 6 days. But that's okay, because we're just, it's 1 to 2 days of actual work, but then there's all this other stuff that happens, right, which contributes to the cycle time. And so I think in the end, it doesn't really matter too much about the sequencing. I kind of like to keep it simple. I mean, there may be cases where it does matter, in which case you could probably add something to help you deal with that. But I don't know. I don't worry about it too much. I just worry about getting people to actually be able to do it. Once you can start shipping reliably, then I think that the other stuff will come. Yeah. Okay. All right. So the next one is about whole teams. So I went to this concert recently, and it was great. The conductor came out and was up there, and he waved his arms around for like 10 minutes, and then he left. And then the percussion section came out. They played a bunch of stuff, a lot of rests they were in there, and then they left. And then the string section came out. They played. Okay, so obviously this didn't happen. That would be the worst concert ever. But that's how we build our software teams, right? So we have these, we set up our organizations so they're built in these kind of gated, siloed communities. And what's interesting is in the China talk about, what was it called? I forget the name of the company, but just before lunch. What was it? Yes, ping right? Yeah. And what he was talking about was, like 15, 20 years ago, we used to build products as whole teams. And then somehow we stopped doing it and separated our business and our IT and our QA in a different department and architecture separately and all these things. And now, like, we're trying to get things back together. And I know that there have been a few talks where people have talked about, okay, well, it's not necessarily that important to worry about the team, just worry about mapping out your process and improving that process. But I think inevitably you gain massive improvements from creating that whole team. And so I think it's a really good target to go for. And it's not an easy target because oftentimes these organizations have built up. One organization I was working with recently, the QA group, the architecture group, and the development group all reported up through different hierarchies all the way up to the CIO. There was no intersection anywhere else. And so the only way to get any sort of cross-pollination there was you would have to actually engage the CIO to help get that to happen. And that's not effective. So I think this is super important. And I don't know how controversial it is really, but maybe I'm just pretending it's controversial. But I think it's a great idea. Do you guys like whole teams? Or do we like working in silos? I don't know. I mean, it's also more fun. You get to actually deliver something. And the idea of a whole team is that you are a team that can take an idea from start to finish, all the way through production, ideally, right? And that's the idea. Even behind in Scrum, right? Every sprint, you're supposed to have a shippable increment and so on. Shippable, not like well, we probably aren't going to ship it. I mean, the idea is to actually ship it. So I don't have any other fancy graphics for this one, but that's the best I could do. So initially respect current processes, roles, responsibilities, and job titles. I think this is true because we're not, what we're saying is we're not trying, by creating a whole team, we're not changing what people do. We're just changing the way that they work together and just talk together. So they're still doing the same job, they're just doing it more effectively. So I think this is a pretty good match here. Encourage active leadership at every level of the organization. I think this, in order to get those whole teams formed, you do need to have people who are willing to step up and say that this is something that's important and will be helpful. Okay. Improve collaboratively. Obviously, we have to, if we're working in a whole team, we are collaborating. And implementing feedback loops. So again, a lot of this stuff is about feedback loops. And if people are working together in a room or very closely aligned, then your feedback is going to be much faster rather than having to wait through another phase till it gets to the QA department and so on. Okay. All right. So the next one. This is one of my favorite topics, which I think I said about another section already. So I guess I was lying. This is simple design. So is anybody here familiar with simple design? All right, cool. So this is a book written by a friend of mine, actually, called Understanding the 4 Rules of Simple Design by Corey Haynes. And I'll just get right into it. So there are 4 rules. First rule is that it passes all the tests. So this is when you're writing code and all the tests should pass. This is just a little video of the Eclipse IDE and just running a bunch of JUnit tests. I don't know if you can read the numbers from the back, but there's 17,313 tests that it's running through right now. Usually when developers are working, they will run, at a minimum, the section of tests that they're currently working on. Our continuous integration server will, of course, be running all of these tests all the time. But in this case, you can see it took about 24 seconds to run those 17,000 tests. So that's not too shabby. Gives us a pretty good, gives us a pretty good confidence that our code is working. So that's the first rule, passes all the tests. And I think this is just an example of an explicit policy. It has to pass all the tests. That's it. There's no question about that. Okay. And of course, feedback loops. So as soon as you see if there was any sort of failure, then this green bar here would turn red. and you would know right away, within 30 seconds that you broke something. So you need to fix that before you commit it. All right, the second one is don't repeat yourself, or dry. Okay. So this is going to be the first time this year, at least, that there's code shown in the Kanban conference. So here we have a method. Everybody familiar with their Ruby coding? Yeah? Okay, good. All right. All right, so this is just a method, basically like a function. So if and it's called create regular user, and it takes a parameter of ID. Okay, there's really not that much code here, so don't get worried. So the first thing that this method does is create a new user, and then it assigns the ID to whatever parameter was passed in, and that's it. That's what the method does. It creates a regular user. Okay. So then we get a requirement that says, oh, well, we need to create administrative users. So, well, what do? We create another method called create admin user, and we grab our old copy and paste, and we select that other code up top. We copy it, and we paste it down here. So we're creating a new user and assigning the ID, and we're also setting this administrator flag to true. Okay, so now we've got two methods, create regular user and create admin user. And as you can see, there are two sections of code here which are repeated. The user equals new, user.new, and user ID equals ID. This is bad. Why is it bad? Why do we care? All right, so the reason we care is that our next requirement now comes in. And the requirement is that we should set a password expiration on a user. Okay? So, somebody else who didn't work on this original feature, or this administrator feature, comes into the code. And of course, these are, there's a bunch of other code in the middle here. So these two methods aren't next to each other. And so they come in and they say, okay, well, I need to add some expiration. And so they add a new line here. It says user.passwordExpiration equals 2017, 12, 31, or whatever. And so that new code is there, except the problem is it's not down here. It's not down in the bottom, right? So now regular users' passwords are expiring, but admin users' passwords are not expiring. This is bad. Okay, and this is how security holes and bugs get created. Okay, so what should we do instead? So we have this duplicated code. The way to address things like this isn't necessarily the best way, but this is just an example of how you can address it, is to essentially delegate back to the first method. So where we had before these two blocks that were identical, we now, in this create admin user, we simply make a call back up to that create regular user. So when it comes in here, it creates the user using this stuff, whatever's up here. Okay? And then additionally sets that admin flag to true. Okay? So now when our requirement comes in for the password expiration, we add that up here. And since this guy is just simply delegating up to this, it gets that behavior as well. Okay? So that's the idea behind don't repeat yourself. Is that clear? Yeah? Okay. It wasn't too much code, right? There's a little bit more coming. Okay. All right, so what do we do by this? I think this is a good way to limit work in progress because you're not having to worry about, keep too many things in your head, like, oh, I've changed this thing over here, I've changed this thing over here. You always know that a single set of logic is located in a single section of code. Okay. And this is an example of refactoring, which I'm going to get into a little bit more later as well. But pretty much any kind of refactoring is this, there's an explicit agreement to pursue evolutionary change. So that's what it is. Refactoring is evolutionary change. It's not a drastic overhaul of the system, as we'll get to soon. Okay. All right. The next one is reveal intent. Okay, so this is the third rule of simple design. How are we doing on time, by the way? 20 minutes. Okay, good. All right, so reveal intent. All right, so we've got a method up here. It says the method is called process. It takes a parameter called amount, and it multiplies the amount by 0.6. And that's the result. So what does this method do? What is the purpose of this? What's the intent of this method? Anybody? Any takers? Well, that's exactly it, is that we have no idea. The intent is not revealed. So this is a bad example of revealing intent. So how would we fix this? Well, it turns out that this code is, and I'm making this up, of course, but it turns out this code is actually about sales tax calculations. So the way to deal with this is you rename this thing from process to calculate sales tax amount. The other thing that's interesting here is that it's a common habit among programmers to do things like this, where we have AMT, which really means amount. Now, we're luckily in the day and age that we no longer have to worry about saving characters in our source code files because of memory constraints. So we can do things like spell out the word amount. We don't need to say AMT any longer. Okay, so we can say calculate sales tax amount, and it's the amount times 0.6. Sounds reasonable. And it actually just occurred to me that it shouldn't be 0.6, it should be 0.06. So sorry about that. That's terrible. That would be a terrible sales tax. Okay. That's why you guys didn't know what it was. Otherwise, you would have known, right? Okay. Yeah. Sorry about that. Okay. All right. So right now it says amount times 0.6. And this, when we see numbers like this, this is what we call in programming a magic number. Okay. So magic numbers are numbers that just appear out of nowhere, and we have no idea what they are. It's just magic. And so really what this is the Michigan sales tax rate of 0.06. I'm trying to, no one's going to move to Michigan anymore otherwise. And so now we can define this constant called Michigan sales tax rate, give it 0.06, and now our method says calculate sales tax with the amount, and it returns the amount times the Michigan sales tax rate. Much clearer, easy to tell what's going on when you just read that method. Okay? So anybody coming in to read that could probably figure it out and know how to modify it if they needed to. Okay? So this again is another example of refactoring. So agreeing to pursue evolutionary change falls under that. And also visualize, I think, is a good match for this because you can actually see what's happening. So, okay. All right. The fourth rule of simple design: minimize the moving parts. So we have our awesome feature that we decided to build. The traveler can book a one-way flight that starts at Detroit at 10 a.m. and arrives in San Diego at 1:25 p.m. That was actually my flight. So, all right. So when we decide to start building that feature, we sit down and we say, okay, well, we're going to need to have some sort of booking system class that will do the booking itself. That's the thing that you actually interface with. Then obviously we're going to need some sort of traveler or object or something like that. And we will need some sort of one-way flight bit that's going to hold some logic about that. And well, since we know that the round-trip flight stuff is also going to be coming soon, we need that thing. And there's probably some commonality between one-way flight and round-trip flight, so why don't we'll build a little abstract base class or something like that. That's our flight, that both of these one-way flights and round-trip flight can share some logic in there. Well, that flight thing has to deal with times, and so we need some sort of time management thingy, so we'll have a time range object. And of course, the traveler is a type of person. We might have other people in the system, so let's make another kind of like a generic type of object called person. And of course, our flights go to airports. Our one-way flight has a starting point and an end point, so we've got two lines going there, so two references to two different airports. And of course, our round-trip flights could potentially have three different airports, right? If it's a jawbone flight or something like that, or maybe we need another jawbone flight class. I don't know. So there's a lot of stuff, and this is not what we want to do. Okay, this is a lot of work to build a one-way flight. That little piece of functionality we're trying to build. Okay, so a better way potentially to start is to say, okay, well, we're going to need something again, some sort of booking system that we are going to interface with. We have our little traveler guy, and we have some sort of one-way flight thing that keeps track of the start time, end time, has an origin and a destination in it, and just be done with it, and that's it. And then when we start building the other things, if and when we get around to wanting to build a round-trip flight or whatever, we'll know more at that time, and then at that time we can start adding those other classes and refactoring. Okay? Does that make sense? Yeah? Okay. All right. So this limits work in progress, so we don't have all these classes that we're working on at one time, that most of them aren't even going to do anything. And I guess that's all it does. So, all All right, so the next one. So that's simple design. Simple design, I think, is very, very cool. I think it's something that's not well appreciated by a lot of developers at this point, unfortunately. There's a lot of focus on some things like there's like the solid principles out there that have been popularized, and I think those are, while interesting and good things to know, I think they're a little bit harder to understand. And I think if you pay attention to these four rules of simple design, you almost inadvertently start following those solid principles. So it's a nice set of easy to remember rules. All right, collective code ownership. All right, so, oh, look at that. That wasn't supposed to happen. There we go. Okay, so this is how most, or not most, this is how a lot of teams are set up, where you have a developer that controls component A, a developer that deals with component B, C, and D, and so on. And this could be a database, it could be whatever, any sort of different component of the system. And when you need to change to that system, you go and ask a specific person to go and do that thing, or that person says, oh no, that's my bit, I will go and do that. When we start talking about collective code ownership, kind of did the reveal on my fancy animation, but what we're really talking about is getting all of the people involved to own all of the code, right? So collective code ownership, pretty straightforward explanation of what it is. And the idea there is so that anybody could work on any bit of the code at any time. This is kind of the liquidity concept. And there's been some, I don't know how rigorous the studies have been, but there have been at least some anecdotal studies that talk about having, if you have 4 developers on the team, anytime a change comes to the system, whoever is the least knowledgeable about that part of the system should actually work on it. And they have to be competent, of course, but the least knowledgeable person working on it will then enable that person to gain knowledge about a particular part of the system. And also, when some sort of critical problem comes in or some more urgent thing, perhaps one of the more expert people will be available still to work on that thing, and they won't have to drop the thing that they were working on in order to work on it. So this works well in collaboration with things like Slack and things like that within Kanban. I don't think Slack is one of our core principles, but I mapped this to this encourage acts of leadership at every level in your organization, because in some organizations, this is really hard for developers to handle. And so people can get very possessive about their code, and there's a whole variety of reasons for that. It can be anything, it can be pride, it can be potential embarrassment because they're afraid their code doesn't look good. It could be I don't know, lots of different things, but it can be a very challenging area to get into. So this, like all Kanban-ish kind of things, are good to do slowly and evolutionarily. Not just like one day. All right, from now on, nobody is ever going to work on their specific bit of code, right? So just slow change is good. All right. Improve collaboratively. Obviously, we're now collaborating on the code. And implementing feedback loops, we now have enabled this feedback between the team members, which they didn't have previously. All right, so test-driven development. Anybody doing TDD in their orgs? Yeah? All right, sweet. All right, so test-driven development. And this is distinct from acceptance test-driven development, which I'm going to talk about next. Okay? So when I talk about test-driven development, we're talking about this red-green refactor cycle. And I'm going to just show you a quick example of what that looks like. So can you see that in the back, in that green color? Yeah? Okay. So this is an example of a test. Okay, so this test says describe tic-tac-toe. It says it starts with an empty board, so when we create a new tic-tac-toe board, then the board should look like this. Dash, 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 where the dashes are representing empty spaces. Okay? So that's what the test looks like. All right, so visualize. So we are visualizing what we want our system to do, okay? And we are limiting WIP, okay? We only are gonna write one test at a time. Sometimes I'll see folks who are practicing TDD write a whole bunch of tests and then go and implement them. When you're doing test-driven development, it's one test, One bit of code to make that test pass, next bit of code to make that test pass, and on and on. You might have a list of the things that you would like to test, but you should not be actually writing those tests, the full tests. Okay? So we write a little bit of code to make this thing pass, and all we're doing here is we're just constructing a board array and whatever, it just creates it. Okay? So that's the green part. So we started with the red, which is a failing test. Then we wrote a little bit of code here, which makes that test pass and turn green. And now we're going to do the refactor step. Oh, not yet. So that's our feedback loop. Our feedback loop is the red-green. So when we get the green, we know that we've got a passing test. So now we do the refactor step. So the very important step in test-driven development that sometimes gets overlooked is this refactoring step, where that first step into making a test pass is done using the quickest, dirtiest way that you can possibly get it to work. And you don't really care whether it's good code or not. You just want to get it done. The next step is refactor, where you make that code better. Okay? And in this case, we decided to extract that little dash symbol into a blank constant. So just to reduce the amount of duplication that we had. Okay? So improve collaboratively, evolve experimentally using models. In this case, I was thinking of test-driven development as the model. It's the red-green refactor cycle. Okay? So then we write another test where we say it plays an X first. So you create a new tic-tac-toe board. If you play at 0, 0, then the board should look like this, where the X is in the 0, 0 position in my coordinate system. Okay? And then we write a little bit of code that makes that thing pass. So you have a little play method, and that sets the row column value to X. Okay? So there's your tic-tac-toe, and now we have a green passing test. That's it. So make policies explicit. I think this one might have been a little bit of a stretch, but basically the idea is it has to pass. It has to pass the test. So, okay. And managing flow. What an interesting side effect of doing TDD, when you start getting into it and start getting good at it, you really get into this, possibly different than what we talk about as Kanban flow, but you get into the state of flow, where you are, you're just kind of like in this little groove of test code, test code, test code. And it's really kind of a fun place to be. And you know that you're always in a safe place because you're only at most, a few minutes away from when everything was working. You're never in this state where I've written a whole bunch of code and I'm not sure if it works yet. I got to pass it off to QA to make sure that it works. You're never really in that state. Okay. All right. So then we get to acceptance test-driven development. Anyone know who these guys are? The three amigos. Right. So the three amigos are our friends here, and we refer to the three amigos in test-driven development as usually like a product owner representative, a testing representative, and a developer representative. It doesn't necessarily have to be three people. It's just kind of three people who have those types of skill sets or roles. On more advanced Agile teams, even those distinctions tend to get very blurry as to who's doing what, but having business representation in there is critical. Okay, so and the way this works basically is you have a red feature, so you write a little bit of text essentially that says that you have a failing feature, like at a high level. You then go through this little test-driven development cycle that we went through previously, and you keep doing that. As a developer, you'll keep working on this test-driven development cycle. At some point, after you've written a bunch of these little micro tests, that feature will start passing, and you then do some refactoring and then start over again. Okay, so it's kind of like a big outer loop of test-driven development. Okay, and an example of, so limiting WIP, again, we are only dealing with one feature at a time when we're doing this. We're not working on a whole bunch of features at once. And we're making policies explicit. So, you have to have those three roles represented within these meetings when you're doing this type of thing. So, and then the other one is managing flow. Okay, so again, you get into this flow state, and you have feedback loops, obviously. And this is an example of what a acceptance test might look like. So given Tony Traveler is booking a flight, when she completes payment, then she receives an email confirmation. So this is something that you'd sit together with your business owners and testers and so on, and you would come up with something like this and then build it. So you visualize what the feature should actually be doing before you start working on it. And this is actually a executable test. So it's like your user story itself is executable. So it's a nice way to do that. And improve collaboratively. Obviously, we are working together with some other people. So I'm going to go quickly through these last ones. All right, so we only have 5 minutes. So refactoring. So refactoring is a process of restructuring existing code without changing its external behavior. Sometimes you'll hear people say, oh, I'm going to refactor this code so that we can handle this new data type. That's not refactoring. That's adding a feature. Okay, refactoring is no changes to the behavior. It's just improving the code to make it easier to work with. Here's an example where we kind of have this. I'm going to skip through this one a little quickly, but we have these two sections of code about calculating the gross domestic product in different ways. It's a little unclear as to what exactly is going on. What are these two different sections? We can refactor this out into two separate methods called GDP income approach and GDP spending approach. I looked this up on Wikipedia. I don't know anything about this. And so then we have these two separate methods called income approach and spending approach. It looks kind of interesting, but that's probably all I will ever know about it. Okay. So we agree to pursue evolutionary change. That's what refactoring is. And I'm actually going to skip over evolutionary design, but basically the idea is that you're building something. This is a picture that Heinrich Nieberg in Switzerland has used quite frequently, but it's about building useful products the whole way along, rather than these little bits of useless functionality. Instead, we have something useful all the way to our car at the end. Okay? All right. So I want to get to the most important one, or one of the most important ones. When you don't pair, it makes pandas sad, so you want to pair. Because you don't want to look at that face. Okay, so pair programming. This is pair programming. So we're sitting together, working on a screen together. We've got a keyboard and a mouse that we're sharing. We're talking about it. The bottleneck here is not typing, so we don't have to worry about people not typing fast enough. Okay? This is an example of not pairing. This person is not being helpful at all. Okay? Good pairing. So these two are working quite effectively together, it seems like. This one is interesting. It's a different kind of pairing setup where they're looking at two different monitors, but the displays are mirrored to each other. So that can make it easier in some cases. There's lots of different ways to pair, and I think this one can work. It just depends on who the people are. Okay? Your cat doesn't count as a pair partner, so this is not pair programming. I don't think it's programming at all. I'm not sure what she's doing. Okay. Maybe she's building a website. Okay. So, and this one, it doesn't seem like it's pair programming at first, but just the proximity of them together makes it seem like it probably is. I don't actually know what's going on in this picture, but basically they have lots of information up, and they are clearly sharing all of that information and working on some sort of problem together. So I'm out of time, and I will leave you. This is also not pair programming, and but I will show you. So these are limit width, blah blah blah, and this new thing. This is the last thing I have, but is about mob programming. And I will just leave you with a quick video of what mob programming looks like. This is a team that I was working with pre-Beard. And this first part is actually not the programming part. This is actually, they're doing CRC cards, so where they're trying to, it's class responsibility collaboration, so they can try and figure out how their system should work together. And they're all sitting around and trying to figure out how the system should work. So that's what they're doing, and then in a minute here it's going to go to an actual example of what mob programming looks like. And feel free to filter out, but it'll go for about 2 minutes or so. And I'll be around to chat with people afterwards. So thank you for coming. Enjoy the music. There they are. Here they're mob programming now.
And then exception agent. Yeah. And then when you want, you do like an expect.
Yeah. One of the interesting things I think to notice when they are doing this is that there's not a lot of action going on the screen. It's all about the collaboration and the talking, and everyone's getting on the same page and knowing what's going on. So this is a really effective technique that's gaining a lot of popularity now. All right. Thank you.